Hello guys and welcome to this OPTM 6421 contact lenses pre-prac video 1 on rigid contact lens fitting. The purpose of the prac is for you to fit rigid contact lenses onto your partners. You all will be working in pairs and perform a complete rigid contact lens fitting examination on each other using the range of trial lenses provided, with a view to ordering a pair of rigid lenses for your partner at the end of the day's practical session. Note that you will have to swap halfway through the prac classes, so that means you should really be efficient with time. Also note that your patient may or may not be willing to go for rigid contact lenses for the 2-week lens wearing experience. You must fit and finalize parameters assuming that the patient decided to wear a pair of rigid contact lenses in both eyes. Because you will be conducting and assuming the partner sitting in the seat is a real patient, you will have to do all the preparation that is required as if you're fitting lenses on your partner or patient. These include good setup and maintaining your personal hygiene, giving all the instructions to your patient, and washing your hands before touching the patient, even before taking any measurements whatsoever, be it keratometry or HVID or palpable fissure height, etc., etc. And also you need to clean the equipment that is required to be used today, and this needs to be done in front of your patient. The measurements that you will be taking include keratometry or corneal topography. Corneal topography is more important if you are considering a pair of rigid toric contact lenses for your partner. Other measurements include horizontal visible iris diameter, palpable fissure height, pupil diameters, etc. You will also be doing a refraction and also record best corrected visual acuity. Performing refraction is important because you may end up ordering a pair of rigid contact lenses for your partner, and if your refraction is incorrect or if you're basing this from a previous prescription, your finalizing of contact lens prescription may be erroneous. Then you need to check eye health before fitting or before inserting any contact lenses on the eye. Then select trial lenses. You know the rules of thumb that those need to be used for these purposes. You may need to consider 1/3 rule when determining base curve for corneas which has toricity more than or equal to 1.5 diopters, and you will note down the lens parameters that you're inserting onto your partner's eyes. You will assess the fit. All the characteristics that need to be observed for rigid contact lenses need to be recorded. And after that, you will perform an over refraction to finalize the contact lens prescription required for your partner in their both eyes. Remember, if you do not get an appropriate fit and you want to change the fit, you will have to insert a next pair of lenses, or maybe you might want to change lens only in one eye because the fit is not optimal. You will have to take another record form and record all the details of the new lens fit that you're performing onto your patient's eye, and then finalize the parameters of the lens in that particular eye. Now, coming back to the over refraction. Over refraction is is the additional power that comes on top of what the contact lens power already is. So you will be using phoropter or maybe trial frame to determine the over refraction values. Commonly, we will be using the most positive or least negative power lens that gives the best visual acuity. You will. The question comes is whether you need to do this over refraction in just spheres or spherical form. Just spherical is good, but ensure that your patient gets good visual acuity by using just the spherical value. But if your partner's vision is not good, in which case you might want to bring in cylindrical component. So you need to conduct a spiral cylindrical or refraction. So this will also dictate whether the lens that you're going to order should be a spherical RGB lens or soft toric contact lens or rigid toric contact lens. So once you have obtained an over refraction, you need to add this over refraction values, the over refraction values that come in the phoropter, to the contact lens trial lens power. So when you're adding this over refraction value to the BVP of the trial lens, you need to know whether you need to correct for vortex distance or not. Obviously, if the over refraction value is more than 4 diopter, be it in plus or minus, you need to use a vortex distance correction if it is more than 4 diopters. Contact lens power determination is a very crucial thing. There are two ways by which we do this: empirical power determination and diagnostic power determination. The empirical power determination we generally use for disposable soft contact lenses when you want to dispense lens on the same day to your partner. Alternatively, if you want to determine the lens parameters and then order contact lenses to your partner on that day based on the measurement that you have obtained without having to put any lens onto your patient's eye, that's what we call as empirical power determination. For example, if you have a patient whose refractive error in one eye is -7 diopters with a vortex distance of 12 millimeters, the contact lens back vortex power required for that particular eye will be -6.5 diopters spherical. However, the diagnostic power determination is used for rigid contact lenses and for soft contact lenses when you want to order a pair of contact lenses. In this case, we will be using the same example. That means if your partner has a -7 diopters of spherical error with a vortex distance of 12 millimeters, the trial lens power is -4 diopters and the over refraction that you would expect in this case is -2.5 diopters, and when you add this -2.5 over refraction to the trial lens power or contact lens trial BVP, which is -4 diopters here, you add these two, you will get a -6.5 diopters, and this is matching originally what you would have determined empirically. Here I give a few examples. Imagine the spectacle power or refraction is -3 diopters for your partner, and you have inserted a -2 diopter spherical lens onto your patient's eye. What will be the likely over refraction in this case? Example 2. Imagine if your partner has -8 diopter spherical and you have inserted a -6 diopter spherical lens, what will be the over refraction value? The final example is -8 diopter spherical, whereas you have inserted a -3 diopter spherical contact lens power. What is the likely over refraction value? Here I want to give a bit more detailed explanation about what happens in terms of calculation or in terms of over refraction value. Is that you have a patient of -8 diopters in the final example, which is example 3, and the empirical calculation of this particular refraction value, when it becomes to as a contact lens power, is going to be -7.25 diopters if the vertex distance is 12 millimeters. So this calculation you would have done mentally. That means, okay, I have a patient of -8 diopters. So what will be approximately the power of the contact lens be like? So -7.25 diopters. Of course, you will not have that particular amount of power BVP trial lens, sorry, that particular trial lens power. So you will have to do a diagnostic, particularly in a rigid contact lens fitting. So in reality, what you do is you have your patient who has -8 diopters. In that particular eye, you will insert a contact lens trial lens. In this case, the trial lens power is -3 diopters. If you have inserted a -3 diopter trial lens, you will end up getting approximately a -4.5 diopters of over refraction. If you add the trial lens power with the over refraction value, you will end up getting a -7.5 diopters of contact lens power. That will be the final power, but that is incorrect because empirically you already know that the contact lens power should be about -7.25. What is happening here is because you have not compensated for the vertex distance for the over refraction value. So that is your over refraction value. You cannot directly add to the contact lens power or trial contact lens power, because here this is more than 4 diopters. So do not add this directly, but instead, if your over refraction value is more than 4 diopters, get a vertex distance corrected over refraction value and add this to the trial lens BVP. Now, if you add these two, which is the trial lens contact lens power and also the vertex distance correction, this time you will get a -7.25 diopters. And it is important that both the empirical calculation and what you get in reality should match. Okay, so there will be some situations where this does not match. So you got to check a few things. Firstly, check the baseline refraction. If your baseline refraction is incorrect, obviously your over refraction is not to the expected value. And sometimes even keratometer readings may be incorrect, and you end up choosing a lens B or ZR which may be incorrect, because that will determine the shear lens power sitting under the contact lens. And sometimes the lens or the trial lens back vertex power that you have inserted during the trial may be incorrect. It may most likely be the case when you have multiple practitioners practicing in a clinic, or even in our scenario where lots of students using the trial lenses. The trial lens label might say something, but originally what is there inside may be different. So ensure the contact lens back protects power is correct. Also, in reality, even though you originally want to fit a contact lens matching the BOZR of the contact lens to the flatter corneal meridian, you may change the BOZR based on the other fitting characteristics. For example, say the excessive movement, or say the lens is too flat, even though you have tried a lens which is matching the on K. So you would change the parameters of the contact lens, particularly BOZR, so that the lens is stable on the eye and it is giving adequate movement and centration. By doing so, you have gone slightly away from the on-K measurements. So when you have done this, you end up getting different tier lens power underneath based on how the BOZR was selected. So that's where you need to remember what is SAM or FAP. Do you remember what is SAM and FAP? Okay, and finally, it's also important that is the over refraction correct? So maybe that everything else is right and your over refraction may be incorrect, because sometimes patients do accommodate through the lenses, the over refraction lenses. So if you're not fogging appropriately, so the patient might be accommodating, and then you might get excessively minus final power. So there are quite a few things, and also I would like you guys to think what will be the order of checking that you will do. Will you be checking the back vertex power of the contact lens first, or you will check over refraction first? So I would want you to think through this slide again and then see what will be the first thing that you will do and what will be the last thing that you will do in a real practice. And there may be some occasions where you may have to prescribe a rigid toric contact lens for your partner, maybe because there's a significant amount of residual astigmatism, or lens is not stable, or patient is not comfortable, or many reasons where you will have to go for a rigid toric lens. I would strongly recommend you to review Alex rigid toric lens before coming to the practice. And when you're ordering a rigid toric lens, I need two important things, and this is what usually the company asks as well. So one is accurate refraction with best corrected rigidity and corneal topography. You need to have corneal topography done for both eyes. And because I will have to send these maps, sometimes companies do ask for me to send these maps, I would want topography to be captured before putting any trial lenses on the patient's eyes. And if you think that your partner requires a rigid toric lens, you should be able to determine what type of rigid toric lens will be required for your partner. I may or may not be ordering the same lenses that you have indicated, but I would like to see your calculation. Once you have performed all the trials, the final lenses that fit appropriately onto your partner's eyes, you need to write down the details of the lens parameters. You need to write all the details that is required, including design of the contact lens. That means you will have to write what kind of lens you have tried on your patient's, sorry, your partner's eye. As simple as type A, type B, type C, or whatever. And you will also have to indicate the final back vertex power and tint. Generally, the recommendation is that we prescribe a green color for the right eye and a blue color for the left eye. So That's the visibility tint for rigid contact lenses. And you are not filling any order form today. I would want you to record all these details in your record sheets. There are quite a few things that you need to remember. Because you would be inserting these lenses on a completely unadapted eye, there is some amount of reflex tearing that you will be expecting. So if that happens, give adequate time for the eye to settle before assessing the dynamic fitting characteristics of the trial lenses. Just be sure that you're using appropriate contact lens cleaning, rinsing, and comfort solutions. Evaluate the fluorescent pattern initially with burn lamp, and as you go close to the final fit, assess using a slit lamp. I strongly advise you to use a Ratten 12 filter because it really enhances the appearance of the fluorescein. You must fit rigid contact lenses in both eyes. That means you will have to use the right left cards. You know what I'm talking about. And once you have assessed the fit and finalize the contact lens parameters required for both eyes, take out the contact lenses from both eyes and store them appropriately as discussed in the previous Prac classes. And then check corneal staining of on both eyes. If there is no significant corneal staining, if it is safe for your patients to go home without any other advice, it's fine. But if you do see any kind of corneal staining that requires some attention, please take the help of the Prac supervisors. And then check ensure that you're covering up the instruments, tidying up your areas, and you're putting things back into the buckets. And that's it for this particular class. And if you have any questions, you can ask me if I'm available, or any other Prac supervisors in the Prac class. So good luck. See you soon.